It's a great delight to be here today to showcase two of the projects which XR Network Plus has funded. For those of you who've not met me before, my name's Melissa Terras. I'm a professor in design informatics within Edinburgh College of Art at the University of Edinburgh. I'm one of the co-investigators of XR Network Plus. Um, the seminars are really important because we can showcase some of the work we've been supporting. And today we welcome two projects that we funded. Those both explore the use of natural language processing tools within virtual production. So what we're going to do today, first we'll hear from Zhuoling Jiang at Cardiff University to discuss their project developing a natural language interface for directing the performances of virtual characters. Then we're over to Edinburgh with Theodore Koterwas, who works in the same department as I do, actually. He's going to share findings from the StyleCat project. And this project developed a proof of concept machine learning model that styles the movements of virtual characters in real time using, again, natural language prompts. But first of all, we need to do a brief introduction to what XR Network is and what we do, because you, the people watching this, might be interested in applying for the type of support which we've given these two projects. So here we go. Here's the map. XR Network Plus is about virtual production in the digital economy. It provides funding and support to researchers working in virtual production technologies. And through the network of partners, and you'll see the map there, many of this was based from the creative clusters. It was funded via the HRC. Then the EPSRC have funded this call. We've been asked to set the research agenda for virtual production, supporting growth and facilitating collaboration between academia and industry on the national stage, but also internationally and showcasing our world-leading cultural and creative industries. XR Network Plus is funded by the Engineering and Physical Science Research Council. So we're really interested in those technological breakthroughs which are helping film, TV, games, and the creative technology areas. Our networked objective is to establish a 10-year research agenda for virtual production. And we're 3 or 4 years in already, and we've got a bank of really interesting projects which are coming out. XR Network Plus is led by the University of York and also collaborates with the University of Edinburgh, the University of the Arts London, Cardiff University, and Ulster University. And working together, collaborating, doing challenge-led innovation are the cornerstones of work within XR Networks Plus. The project's building a community of academic research and industry R&D with a convergence of ideas, technologies, and creative practice. We hope that these will deliver impact, but also opportunities for the whole of the digital economy. So the format for today's seminar, each of the presenters who we funded from XR Network Plus will speak for 10 minutes, Zhuoling first and then Theodore. And then we'll have a joint question session together for 15 minutes. So I also have some questions prepared, but for you in the audience, you're also invited to submit your own questions, either for both projects or just for one. Most of you, I presume, will have used Zoom by now, but at the bottom of your screen, you will be able to submit any questions in the Q&A box, and you can do that at any point in the seminar, and we'll pick it up after both of the talks. So that's enough from me. Without further ado, I'm going to hand over to Zhuoling to discuss the first research project. And just to introduce Zhuoling, Zhuoling Jiang is a PhD student at Cardiff University within the School of Computer Science and Informatics. He's a computing engineer and full-stack developer and was the research assistant on this project. And today he will talk about allowing on-set direction of virtual characters. So I'm going to stop my presentation and hand over to you so you can start yours.
All right, thank you, Melissa. And I'm sharing my screens here. Right, thank you very much.
There we
My
go.
name is Zhuoling Jiang. I'm a PhD student in Cardiff University. I'm also engaged with this natural language interface for directing virtual characters project. So the core research questions we are addressing is actually very simple to state. How can a director using same language-based directing skills they already have to control a virtual characters as if they're directing human actors? This question sits at the intersections of virtual productions, human-computer interactions, and AI-assisted creative tools. In this talk, I will focus on one foundational stage of this research. Um, so in traditional film or animation productions, director work almost entirely through their language and their expression via different like sketchbook or anything they may want to talk with a human actors. They communicate intent, emotion, and timing by talking to human actors. However, when we move into a virtual productions, directing a virtual character, this skill transfer breaks down. As you can see here, controlling a traditional virtual characters typically requires navigating a complex rigs hierarchies, numerical parameters, and a professional complex animation tools. This creates a mismatch. So directors are experts in performance and communications, but virtual characters demands low-level technical manipulation. Our research treats this not a tooling inconvenience, but as a fundamental interaction problem. So if we say that directors should be able to direct with language, the immediate technical questions becomes, how does language safely touch a control rig that's controlling the virtual characters? Language is inherently semantic and ambiguous. Control rigs, however, on the other hand, are discrete, named, constrained, and unforgiving. A naive approach, such as directly generating animation value from text, is very simple, but it's simply unsafe in a production environment. Just like you always have to adjust your prompt and hoping the next time the AI will generate a proper, better result for you. So before we ask whether language can direct performance expressively, we first have to answer a more basic questions that can language be grounded into valid, executable rigs actions at all? Our overall research is structured in phases, and the tool I'm presenting today corresponds specifically to our very first phase. The goal of this phase is not to generate perfect animation and not replacing animators. Instead, we are asking a foundational feasibility questions that can natural language be reliably translated into structured, valid rig operations under real production constraints. If this step does not work, then richer interactions, semantics, and learning is later in those later phases would not be meaningful. To study these questions, we design a system that acts as a research instrument. So the workflow starts with a natural language input from user. The planner components generates, powered by the large language models, generates structures actions plans, which is then passed through a validator that checks control rigs names, value range, and execution safety. Only after passing validation that our actions sent through a bridge into Unreal Engine, which is industrial level, already mature animating tools. A key design decisions here is that the language model never directly controls the engines. Just like you can hear you can hear the news from many other social medias, then some of the agentic AI deletes the entire hard disks of the developers, which is a disaster. But in this case, we separate these two control flow. So these separations allows us to observe where and why failures happen, rather than hiding them inside a black box generation. So central to this system is the use of a explicitly action schema. Each action specifies what control is targeted, what value is applied, and when it happened in time. These structures enable validations, rollback, and inspections. Importantly, this is not just an engineering detail, it's a methodological choice that allows language to function as a controllable interface rather than unconstrained generation. So here is a demo video shows how our plugins in Unreal Engines work and the user experience through this tool.
In virtual production, directing facial performance requires manipulating dozens of low-level controls. For example, in Unreal Engine, you need to adjust every single control rigs in a keyframe to make a smile facial expression in a level sequence. What if directors could instead direct virtual characters using language? Avatar Bridge operates directly inside Unreal Engine, using real level sequences and control rigs. The language model generates structured rig actions, which are validated and applied to the level sequence. The result is not a black box animation, but editable keyframes that artists can inspect, adjust, or revert. Directors can iteratively refine performance using natural language.
So as you can see, we enabled a Unreal Engine plugins that allows user directly using natural language to control a virtual character's facial expression. So because this is a research study, our evaluation on this tool is not based on whether the animations looks good. Instead, we ask three concrete questions. So first is the output structurally valid? So second is, does it correctly reference real control rigs in Unreal Engine? Third, does it satisfy the intent of the task? So we designed task categories that reflects how directors may actually speak into this natural language interface, including single control rigs at a time or multiple control rigs at a time. Sometimes the commands from the directors may including specific body parts. Say the directors may just asking to open the eyes, but the mouth should not be moving. Or just or some adjustment to existing expressions, just like the example in the video. We then have a command says make the smile more subtle, which there is a context that already has a smile expressions there. So the results reveal a clear pattern when language is explicitly and grounded. For example, when referring a concrete facial actions, the system perform very reliably. Structural errors are rare, which confirms that the action-based grounding is effective. The dominant failure mode is semantic reference, such as ambiguous or under-specified descriptions of facial control or facial regions or expressions. These tell us something important, that the challenge is not syntax or formatting, but semantic grounding under creative language. So these findings directly inform the broader research agenda outlines in the XR network proposal. We suggest that language can indeed function as a viable directing interface, but only when it is supported by grounding constraint and system level structure. We also point clearly towards future work, such as richer rig metadata, retrieval-based grounding, and interactive clarification between the systems and the directors. To conclude, our work shows that language can be used to direct virtual characters' performance, but only when it's treated as a controlled interface, not a free-form generations in the like ChatGPT, the chatbot. So this phase established necessary foundations in our long-term visions of language-driven virtual production tools. Thank you very much for today's listening, and looking forward to any questions or idea to share. Thank you very much.
Thanks so much. That was really fascinating. Before we have questions, we're going to pass over to Theodore Koterwas, who is a lecturer in design informatics at the University of Edinburgh and Edinburgh College of Art, in addition to being an artist and a designer. And he's the project lead on StyleCap, which he's going to talk about today.
Great, thank you, Melissa. I'm just sharing my screen here. Make sure it's the right one. Great. Okay, so I'm assuming everyone can see that. As Melissa said, I will be presenting on StyleCap, which was a project funded by XR Networks Plus Embedded R&D. Our industrial partner was Retinize, and we also had some participation by Caerdydd University. So the project was to look at whether you could style virtual character animation with sparse motion capture data and natural language props. The motivation for this, and forgive me for a minute, I'm just going to move my... There we go. Okay. The motivation for this was to make animating virtual characters less tedious and expensive and more accessible and creative using just a VR headset, hand controllers, and text prompts. So instead of using a full, very expensive motion capture rig, you could use more accessible technology. The motivation was decidedly not to replace animators, but to enable them to focus on the parts of the process they value the most, which is bringing characters to life. Animation involves a lot of tedious keyframing between key poses and things like that. So in order to do that, we had 3 research questions. The first was what supervised learning methods and data labeling strategies would be effective, how these results are perceived by animators, and then how these models can be implemented in a system that enables animators to exercise their creativity. We based our technical process on an approach called categorical codebook matching, which was presented at SIGGRAPH in 2024 by Meta and made open source. I won't go into the technical details here, but basically what it does, it takes the full motion sequences that you give it as training data and creates predictions on what future motion will be based on current motion. And then it also predicts the future state of the input, so the person with their headset and their controllers. And then it tries to reduce the probability that those two things match. Okay, so it basically takes the input, matches it to probabilistically to the full motion data. And Retinize, our industrial partner, implemented this with their own data set and got these results. So you can see on the right there that you've got the headset and the controllers, and you can see I was animating a full character. What we wanted to do in this project was see if we could add more information in the way of a style label to say, to style the walking, the animation, to be either more heavy or more tense, or to make them to walk in a bouncy way or a happy way. And in order to do that, there were a couple of ways we thought about. One of the first ways was the traditional sort of obvious way. We've got all this motion capture data. Why don't we try to label it, and describe it with labels, and then we can use that as a data set. Well, that's quite a tedious process when you've got hours and hours of motion capture process. And it also ethically seemed like it was just perpetuating the way that these models get made, where you're asking people to do a lot of really low-skilled labor in order to then replace that labor. So instead, we thought we'd take on an approach that pre-labeled the data. So we'd use the embodied knowledge that actors have to act out the labels in a motion capture studio. And in that way, we already have the labels that align with the motion capture data. And so from there, what we needed to do is we needed to think about what labels, what is this language that animators use when they're trying to style animation. And so we approached this through some qualitative data gathering, through some interviewing. And so we asked some professional animators during a 3-part interview to describe animation style, to direct a live motion capture session and describe the improvements that they'd make to the data that was captured, and then to discuss the tools and animation that they used. In this way, getting them to talk about animation in sort of a productive way allowed us to kind of work out what terms they were using. So in the first part, we asked questions like, what makes an animation good? Are there particular styles that you find effective? And can you describe some of the techniques you use? In the second part, we had them direct a motion capture session. So our collaborator at Retinize has a studio, and when we did the interviews, he remotely acted out a scenario under the direction of our interviewee. And that scenario was a zombie apocalypse scene from The Last of Us, the video game. And that looked something like this. So the interviewee was watching Jack there in the suit and directing them what to do. And you can kind of see over here on the right sort of natural language that they would use. And then the third part of the interview was looking at tools and automation, because we really wanted to understand how to preserve the essence of the craft. We don't want to replace animators as artisans, as artists, as creators. We wanted to enable them to work better and more creatively. Then we analyzed these interviews to determine the labels that we wanted to experiment with. We did this by highlighting some of the phrases that they would use in the interview transcripts. We'd categorize those based on what they were describing. Was it the scale of motion, or the expressiveness of the movement, or the appeal of the movement? And then we also categorized them by principles of animation. So Disney's 12 principles of animation are one of the key ways that animators do speak about animation. They've learned that from their training, and it still dominates in literature. And then we did some word frequency analysis to see which words were used most frequently. And from them, there we predicted which of those terms might best be embodied by an actor and could be acted out. During the first part of our motion capture section, we then asked the actors to do the 20 most frequently used terms, and then we picked 9 of those to capture data for. During the motion capture session, they walked forward, they walked backwards, they sidestepped, they ran forward and backward, which are all motions that you'd expect a character to do, say, in a video game. And here's a video of one of our actors walking in a particularly stretchy way, so you can get a sense of what that would look like. So we trained the model with those labels, and you can see some of the results here. These are characters moving according to various labels. As you're watching this, maybe you can think to yourselves what they might be, and I'll show that in just a moment. So in the first one, this was trained on motion capture data of an actor acting out stumble or stumbling. The second was stealthy, and the third was walking with attitude. In order to evaluate these, we had a focus group of 13 animation and film professionals, and we asked some questions. What is the character doing? Can you describe the style in one word? The movements in one sentence? What 3 words best describe them? How might the expressiveness be improved? And for those 3, for the attitude animation, 5 out of 13 respondents used words that were synonymous with strut, proud, prancing, or swagger, while 7 referred to dancing and 12 referred to positive emotions such as joyful. So perhaps instead of attitude, we got more joyful dancing. And then for stumble, 4 used stumbling, and all the other respondents used synonymous words of closely related terms: tripping, drunk, chaotic, dodging. And for stealthy, all respondents used words that were similar to sneak, creep, stalk, or secretive. In our eventual implementation of this, what we would hope to do would be take those natural language phrases, like dancing joyfully, and be able to use a large language model, and in this case we tested it with GPT-4, to translate that into one of the labels. So from dancing joyfully, we'd want a translation into attitude, and that would then use our model to increase the attitude of the person walking. So to test this, we tested this in 3 ways. We created prompts from the survey questions. So we essentially asked GPT to analyze the video frames and answer the same questions that our focus group did. Then we asked it to look at the video frames and pick one of the 3 labels. And then we asked it to summarize the survey results. And so the results of that, for just giving it the video and asking it those same questions, for attitude, it used the terms expressive, flamboyant, dramatic, and theatrical. It mentioned dancing all 10 times. So we ran the prompts 10 times, because obviously we'd get slightly different answers each time. For stumble, it used the words cautious, uncertain, anxious, reactive. And then for stealthy, the results from GPT-4 were much closer to our animators, using sneaky or sneaky, and creeping, stealthy, and cautious. This was one of the more interesting results, when we asked it just to give us one of the three labels in response to the frames from the video, for stealthy, it shows stealthy 10 out of 10 times, stumble 8 out of the 10 times, and attitude, it shows attitude 10 out of the 10 times. So quite accurate in being able to choose which of those best describe the video. And then finally, in summarizing our focus group respondents, for attitude, it summarized their response for that one word 9 out of 13 times as attitude. And for all of the responses, it chose attitude to best describe them, let's say an average of 3/4 of the time. Stumble, 6 out of the 13, and an accuracy of about 0.75. And then stealthy, also a median accuracy of 0.75. And our project team, so I was the PI, co-investigator from Abertails, Philip Vaughan, and our co-investigator from industry is Jack Morrow from CEO. He's the CEO of Retinize, and machine learning developer Stefano Brughetto from Retinize. And that's all I have for you. Thank you very much.
Thank you. It's very impressive. That's all you have for us, but you know, it's amazing to see how far things have come. So thank you for that. We'll do some Q&A now. We're all here. That's good. I'm just going to check if there's any questions that people have asked. If you want to ask anything, do put them into the Q&A and we'll have a discussion. So I'll start with a question from online from Stephen. This is particularly for Zhuoling. How would you evaluate the goodness of the output, and what does the error percentage indicate?
Yeah, sure. This is a very nice question, and thank you very much, Stephen. So let me just recall with my slides before. Give me a second. So yeah, if everyone can see the table and figure I have shown before, this is a very brief result of our existing evaluations. So as you can see, we have a unified score and a error rate here. So in our evaluations, there is a twofold. So firstly, we enforce gamma constraint decoding and check format errors. So this is the very first part of the error rates. If there is a format error of the JSON schema or the name error which identifies a control rig that is not existed in the MetaHuman control rigs list, in the validation, if we found that error in the validation loop, that will count as a error. And secondly, we also compute a unified score per task, which for different tasks, for different commands, they have different calculation algorithm. For example, for single or multiple control rigs commands, we will calculate the control rig set overlap, whether we have expected some of the control rigs will be applied different value. However, the language model may not generate the specific control rigs which contains some overlap. That's why we calculate this kind of overlap set size as a score. We also have a value accuracy scaling for different tasks, and in body parts or adjustment commands, we calculate different like region coverage or the coverage with the penalty of extras. Like for example, we already have a smile face, and then some of the control rigs is already has some value from the default value. And then if the adjustment commands generate some control rigs value that is out of the expected control rig, which will has a penalty score in this unified score. After all these calculations, we normalize all of the different commands and then calculate a normalized score to let us compare across categories with a single number. So this is the very basic way we can quantitatively to evaluate the current plugins, and this is also the results we present here. For the next questions here, how much effort it will take to integrate this plugin to other characters, which is also one of the methodology considerations when we're choosing Unreal Engines and MetaHuman as our technical stack, because MetaHuman is a very mature virtual characters creating tools provided by Unreal Engine's Epic game. It has already published for over 2 or 3 years, and these kind of pipelines has a mature way to change or map into a different 3D outfit, 3D appearance, 3D models of different characters. Even you can using an iPhone to capture your own face and create a visual character for your own, and just mapping into existing control rigs and all of the bonds and hierarchies of the virtual characters inside Unreal Engine. This has there are plenty of tutorials and also some tutorials, including some existing example you can download and test for yourself from the internet or YouTube. So I believe this is a very easy way to directly mapping into different characters, as long as the character is a humanoid-like. So I won't say this is a very difficult thing. So it's a very simple and mature thing.
Thank you very much. What do you think, or where do you think these kind of tools are best embedded into a production environment? And have you talked to anyone about how they might be used within actual animation or studio facilities? I think Ted, you'd said that you'd run this past people, and where do they see these tools kind of fitting in what they're already doing?
Yeah, so this was one of the main foci of the interviews. So in the third bit, we really wanted to understand the tools they use and what they wanted those tools to do for them and what they wanted to do for themselves. And it became very clear. I mean, every animator that we talked to viewed it as a way to save them from the tedious effort of between key poses. So in animation, generally you set the key poses of a character, and then there's some painstaking work setting the in-betweens between those and then tweaking them to get the right the right style or the right character of movement. And this was unanimously the most tedious part of the process, and the process that they felt kind of took them away from the act of creation, or the creative experimentation and flexibility of the tools to bring a character to life. And so it kind of interrupted their workflow, and this would be a way to keep their workflow solid. So in this case, what we were developing was very much focused on a tool that Retinize is commercializing, which is a platform for animating characters with a headset and 2 controllers. And so there's a very clear pipeline for integrating this model within that. And they've already integrated the 3.2 full body motion capture into that tool. And we need to mature this model a bit more in order to then implement this. So there's a very clear path.
Thank you. What about you, Zhuoling? Have you talked to anyone about where this might actually fit into the current production pipeline, or how it might disrupt it?
I am an agentic AI researcher. I'm also an engineer building multiple tools around the agentic AI, leveraging large language models and other natural language processing technologies. So I'm very excited with the current potentials and existing progress that using language using agentic AI and large language model related technology to helping those users may not have the very professional skills joining our virtual productions industry. For example, in software developing industry, we have the concept of vibe coding. The user does not need to understand the deeper programming skills. They just need to tell the agentic AIs what I want, what kind of the websites looks like. So what if the user, those don't have the professional skills? They can directly using natural language tells the agentic AI says, I just want to have a human that is jumping happily, and then our agentic AI and other tools that are already integrated in our virtual production tools that can generate the production ready level the visual productions like characters, animations, or the scene scenarios that help the holding the entire characters and visual productions. I would say that will be a very potential area that we can take much more effort to do some research around that. So I believe the current progress is very beginnings, and uh, we can also get involved to like make the more building up more powerful tools that helping people get into these production industry.
Thank
I might
you.
also just jump in there a little bit and just because I think there's a second part of your question, or maybe it's implied in your question, which is around these tools' potential to cut creative practitioners out of the process. That if you automate some of these tools, or you make it that much more accessible, that anyone can create an animation. Well, what happens to those who are highly skilled and who have spent a lot of time perfecting their art and using older tools for doing this? And I think it is a really interesting question, and there's been quite a huge backlash against AI based on this and on IP, all of that. And I think one of the ways, so I think the primary way in which we want to see this develop is in co-development with artisans and creative practitioners, that we are working with them to understand how tools like this, and we ourselves are creative practitioners and have some of the same values, and we want to make sure that those that are impacted by the tools and the use of these tools are the ones that are designing it, and not necessarily having it designed and for them or over them. So I think that's quite important.
Thank you. I liked your comments about labour in your talk as well, Theodore, when you were talking about how a lot of these big tools can be extractive, but actually you're trying to build something which adds or takes away the boring bit of the job, allowing people to do the more interesting bit and making sure that you're not falling into that trap. I was going to ask a few questions about the NLP side of things, but Stephen in the chat has asked one of them. He says most of the time NLP works out of the box, but how do you see cases where it doesn't follow the intentions? Do you think having a constrained set of language, the vocabulary for animation, for example, to bound expected behavior is something practical for real world cases, especially when there's non-professional users? So how do we have that bounded vocabulary which people could know to direct the tools? And how does that link to NLP and large language models?
I'm happy to jump in if you
Yeah.
want. I mean, I think that was one of the key areas that we were trying to look at. We were trying to understand what, in general terms, that language might be, or what is the vocabulary that people who would use this tool professionally would be using, and what's the nature of that language, and can that be translated, or can that actually be filtered down into a number of different labels? So can stretch, which is quite a general term for motion, can ways that people might say, I want this character to be more elastic, or I want this character to walk in a more exaggerated way. Is it then possible for that to be filtered down into a label that can then work in a supervised learning situation? I think, and we got proof of concept for that. Obviously, I think you would need a much larger set of labels and set of motion capture data to make that practical. But but it is a balance between trying to limit, or I would say limit is maybe the wrong word, but focus your efforts in the area where it's most probable that it'll be useful. And you can only really do that, in my experience, through sort of qualitative research and talking to people and understanding how people will end up using it, the way that they speak in practice, and things like that.
Thanks. I don't know, Charlene, if you've got any thoughts on the type of interactions that you have to have with NLP to drive this system.
Well, I have some experience while using the NLP driven agentic tools that helping me to create whatever softwares or animations and in virtual productions. I would say in the current progress with those large language models, we found large language models can be a great translator from those free-form, unstructured natural language input into very structured and well organized data or informations into the following tools, which that's why we consider the large language model as a interface to helping the user to express themselves, express their intentions and opinions, and then translate into something that can apply into a professional tools. I would say the NLP is a very enables technology in here, and I'm hoping the more technology can in the downstream after the NLP translators, we can do more things around like what can the large language outputs can do with our professional tools. And
Thank you. It's really interesting. I'm trying to get my head around a slightly different question. So I've done some work on NLP, particularly in inherited biases in language and large scale data sets. And we know that these large scale models are highly biased, right? But the work that you're doing is so determined on the kind of the verb languages, the doing languages. Do you have to think at all about how the biases contained within these LLMs might be affecting the outputs of your animation? And I'm just trying to work through what that would actually look like in practice or how you could even determine that. But just
I
throwing it
think
out there, is there any data ethics component to this?
there definitely is. I think. However, I think the reason, or I'm struggling, I think as well, to try to work out where that falls, because I think at the moment we're at proof of concept sort of research, and so does this fall more in the how you implement the model, how you implement the model that you've developed, because we're filtering a large amount of variable language down into very concrete labels, and it's in that filtering that is probably some of the bias that is happening. And then there's bias that could be introduced in the fact of who are we selecting to embody these terms when we go into a motion capture studio, so it can creep in there as well. And so there's that. So it's that the assumptions that we're making. I mean, we made a lot of assumptions there about, oh, can an actor embody the term stretchy, right? And so in our minds, obviously, there's an actor embodying that. Who is that actor? What shape are they? Who are what physical, what sort of ableist assumptions are we making? All those sorts of things. So it does come in, and whenever you reduce something like the capabilities or the expressiveness of a human body or the expressiveness of language down to something that can be quantified, that's where all the biases come in. So it comes in at all these different levels. And I suppose the way that I can think of to do it, well, there's two. There's sort of peer review. Can somebody else who you're working with point out some of these issues that you've overlooked? The second would be in, again, inclusivity of who's helping you conceive these models, who's helping you evaluate these models, and who, in the end, is even asking for them.
Thank you. I don't know, Zhuoling, if you've got any thoughts on that.
Well, so as a machine learning engineer, I sometimes deal with the model's bias because of the data sets sometimes has containing bias, which is very natural in machine learning research. However, I will believe because the model itself is just one of the components of a huge system. So for example, in our avatar bridge. The language model is just a very small component that generates the structured status here. However, there are plenty of other components around us, including the validator, including we also have the human feedback part, like we are developing a interface that allowing users to adjust the output from the existing language models, or even in other agentic systems, we also have the evaluations or review stage that allowing users or allowing the real professional people, like Nora says, we may have other like peer review stage. So models or machine learning or NLPs itself is not the whole system, so it's just a very small components. Other parts in the systems can take all the efforts to help us to avoid like bias or any other risky any other risk around whatever the ethical thing, ethical concerns, or even other safety concerns here.
Thanks. Yeah, and it's fascinating, isn't it, as these systems get more mature and how difficult it is to even think about how people would raise these issues unless we build in checks and balances, or the opportunity for peer review, or the opportunity for knowledge as to where the different types of data was getting embedded. And you know, I'm sure that in both of your projects you're taking care about that, but we have to make sure that the products that are then hitting general market are aware of this, because as everyone knows, we've seen some issues with that. So yeah, it's really fascinating to talk that through. Well, thank you very much. I'm aware of the time, so I'm just going to move on to wrapping up. I don't see any further questions in the Q&A, but that's been a really fascinating discussion. I'm just going to share one final slide, if I can find it. Let me just oh, 1 second. Oh, sorry, it's not letting me share the latest update slide. There we go. I'm starting it again. Share, and I will put this on to share. Here we go. Okay, so thank you to both of the presenters today. That was a really fascinating discussion, and thanks also to those of you for joining, and thanks Stephen for your 4 different questions. That was great. This is our final seminar of this sequences of seminars, but we're going to have another series, and there's plenty more to look forward to from XR Network that's coming up. And the next roadshow that we're having is at the University of Nottingham on the 24th of March. And we will be sharing more information about that in coming weeks. So do please sign up on our webpage and the newsletter if you've not signed up already, and you'll be able to get more about that. We have a white paper that's been out from our R&D challenge with the Royal Shakespeare Company, and that shares the findings of both the challenge projects led by Half Camera and the Royal Central School's Art Drama, and they are available on the XRNet Plus website. And our next R&D challenge funding will be later in 2026. So fan experience. So if you want to know anything more about that or any of use that code. You visit the website, do follow us on LinkedIn, and listen to us and sign up to our newsletter. So thanks again for joining us today, and most of all, a big thanks to Cardiff and Theodore recommendations for the work they've done. We really depend on our networks and our partners and doing the work and most of all that networking to support it. But it's really wonderful work of researchers such as this, which is spreading forward creative technology, particularly for the creative industry. So thank you very much. It's been a delight to have you. Thank you.